Okay, we'll look at one example of an equation which is not a quadratic, but which can be converted to the quadratic. So if you see 2x power 4 minus 5x square plus 3 is equal to 0. So it's very clearly it's a biquadratic. So I need to convert it to a quadratic if I want to solve using the quadratic formula methods, right? So it's x power 4 here and it's x power 2 here. But I know that x power 4 is equal to x square the whole square, isn't it? So what I will do is, I will write x square is equal to y. This is my substitution. I can do that, isn't it? I can substitute. So I get 2 into x power 2, the whole square, minus 5 into x square plus 3 is equal to 0. So now you see what happens. What is x square? Y. Wherever there is x square, I put y. So 2, in this place of x square, it is y square minus 5, x square is y, plus 3 is equal to 0. So now this is the form ay square plus by plus c is equal to 0. So this is a quadratic in y. All right. So remember, we have used the substitution x square is equal to y. If you compare, you get a is 2, b is negative 5, and c is equal to 3. What is a into c product? It's going to give me 2 into 3. Okay, wait. A into c. A into c is 2 into 3, which is 6, right? So now I need to get, if I develop the factor tree and I get the factors, 2 3s are 6 and 6 1s are 6. Also, I want positive 6, right? I can say minus 2 into minus 3 is also plus 6. And I will choose this nodes. Why? Because I want b. B is negative 5, right? So when I add this set of factors, I get minus 2 and plus minus 3 will give me negative 5. So I'm choosing this. So therefore what happens? 2y square minus 5y plus 3 is equal to 0. I can write it as 2y square. I'm splitting 5y as what? Minus 2y minus 3y plus 3 is equal to 0. Now we will club. We can use Sridharacharya's formula also, but we have used quadratic into say factorization here. It's relatively simpler for me. 2y into y minus 1 minus 3 into, I can write 3 as 3 into 1. 2y is 2y into 1 minus 3 into y minus 1. I've taken out minus common, right? So I get y minus 1 and 2y minus 3 is equal to 0. Or y is equal to 1 and 2y minus 3 is 0 gives me 2y is 3, which is nothing but y is equal to 3 by 2. Okay. So I have got 2 values for y. Because why 2 values for y? Because y is a quadratic, right? I mean, it's a quadratic in y. It's a biquadratic in x. So y is 1 and y is equal to 3 over 2. Now see what happens. You have to back substitute. We'll do that. I have taken y is equal to 1 and the other thing is y is equal to 3 by 2. What is y? X square is equal to y, isn't it? So x square is equal to 1, or I can say x square minus 1 is 0. I can write 1 as 1 square, isn't it? Now it's of the form a square minus b square. So I get a plus b into a minus b is 0. So when I equate x plus 1 is 0, I get x is equal to negative 1. I get x minus 1 is 0, x is equal to 1. So x is equal to plus or minus 1. That is when I consider y is 1. And if I consider y is 3 by 2, so I'm writing x square is equal to 3 by 2. Isn't it? So x square is equal to 3 by 2. I'll just go back. Y is equal to 3 by 2. Let me just see here. So x is equal to plus or minus root of 3 by 2. So see, if I'm going to use tables, I can write plus or minus. I can rationalize inside, isn't it? 3 by 2 into 2 into 2. See, preferably we want to keep the denominator free of the irrational component. So it will become plus or minus root of 6 by 2 into 2. And so in the denominator, I can write plus or minus root 6 upon 2. Okay, root 6 value, if I'm going to substitute and if I'm going to divide by 2 from the tables, it will be 1.222. Okay, so plus or minus 1.22. This is the value. So that means I'm getting 4 values of x. Plus or minus 1 and then plus or minus 1.22. Why 4? Because It's a quadratic in y. So this is an example of a problem where, it involved a biquadratic and we converted it into a quadratic and solved it. So I hope the explanation has been clear so far.